Hello students, I am Dr. Varun Mohan from ABES Engineering College, Ghaziabad. This is the lecture 3 of the lecture series of Unit 3 of Engineering Chemistry, BAS 101 and BS 102. Today we shall discuss about batteries. These are the contents of today's lecture. First we shall define what is battery and we will discuss about its types. After that we shall highlight the differences between primary and secondary cells. We shall focus on the performance requirements of a battery for its commercial applications. After that, we shall discuss the construction and working of dry cell and lead acid storage battery. And at last, we shall discuss about some questions which have appeared in previous year's exams. First, we shall define battery. So batteries, the combination of two or more galvanic cells electrically connected to work together and produce electrical energies are called battery. The batteries act as portable source of energy. As per the requirement, various combinations of electrodes and electrolytes can be used to make batteries for specific applications. A variety of electronic gadgets have been made more useful and popular with the introduction of rechargeable storage batteries, having better reliability and portability, better shelf life, and tolerance. So on the basis of type of cells used, the batteries may be of two kinds: primary batteries and secondary storage or accumulator batteries. Primary batteries are those which use primary cells, and secondary storage batteries are those which use secondary cells. Primary cells, these are the cells which have fixed amount of energy stored in them. Once that energy is used, they become dead, they become exhausted, and they cannot be recharged. In other words, the chemical reactions happens only once in them, and only one continuous or intermittent discharge can be obtained from them. Examples of these cells are dry cells or Leclanché cells. Secondary cells are those cells which can be recharged after partial or complete discharge, and these can be used again and again. So the cycle of charging and discharging can be repeated for a number of times. After discharging, these can be restored to their original condition by forcing an electric current through them. Examples of these cells are lead storage, the cells used in the lead storage batteries. We shall see now what are the basic differences between primary and secondary cell. Recharging is not possible for the primary cell, so those cannot be recharged. Secondary cell can be recharged and reused. Reversibility, the primary cell does not have reactions which are reversible, so it has irreversible reactions. These are irreversible in nature. Whereas secondary cells have reversible cell reactions, so these are reversible. In terms of design, those don't have any fluid. The primary cells don't have any fluid. That's why these are called dry cells. Here the electrolyte is in the form of paste. Secondary cells are having the electrolyte as fluid or the molten salt. So these are wet cells, and these are, or these may be the molten salt cells. Molten salt cells. On the basis of usage, these can be used only once. whereas secondary cells can be used for more than once. Internal resistance in primary cells is high, whereas in secondary cells, internal resistance is low. Discharge in primary cells is low. They have slow discharge, whereas primary cells have slow discharge, whereas secondary cells have high discharge. They have higher discharge. The primary cells are used where we need a small but constant current, like toys or clocks. Secondary cells can be used where we need portability. So that it can be charged and discharged again and again. So the electronic devices like laptops, mobile phones are the examples of the application. These are cheaper, easy to use. Primary cells are cheaper and easy to use. Secondary cells are expensive. They are more complex in their usage. So expensive. So these were the difference between primary and secondary cells. For commercial applications, a battery should fulfill certain criteria. And the very first criteria is high capacity. High capacity refers to the variation of voltage during its discharge should be minimum. Then it should have high energy efficiency. Energy efficiency can be shown as percentage energy efficiency is equal to the energy released on discharge upon energy required for charging. Multiplied by 100. So if for a battery, the energy released on discharge is almost similar to the energy required for charging, then it have very high energy. It has very high percentage energy efficiency, which is desirable. High cycle life. Cycle life refers to the number of charging and discharging cycles before its failure. It should have long shelf life. It should show tolerance to different service conditions like temperature variation and shock. It should be reliable and safer in its usage. So those are certain criteria which should be met for the commercial application of a battery. Now we shall discuss the construction and working of the dry cell or Leclanche cell. This is the dry cell shown here, and this is the vertical section of the dry cell. Here we can see there is an outer covering. This container is made up of zinc. Inside there is a rod made up of graphite. This is called the carbon rod. And outside this carbon rod, this graphite rod, there are some electrolytes uh, filled in the form of paste. These are manganese dioxide, ammonium chloride, and MnO, the carbon cut. Now we shall discuss about the construction working of dry cell or Leclanche cell. This is the picture of a dry cell and its vertical section. We can see outside there is a zinc container, and at the center there is a graphite rod. The graphite rod is surrounded by manganese dioxide, ammonium chloride, and zinc chloride. Here, the zinc container works as anode. It's shaped as container for keeping the electrolyte. The At the center, the graphite rod works as cathode. This cathode is surrounded by an electrolyte, this MnO2, ammonium chloride, and zinc chloride. These work as electrolyte, and some amount of starch is added to it to make the electrolyte thick like paste. To prevent its leakage, the cell is enclosed in polypropylene cylinder. The dry cell couple gives the voltage of almost 1.5 volt. Here the anode is zinc. The electrolyte is the paste of ammonium chloride, zinc chloride, and MnO2. And the cathode here is graphite rod. So the cell can be represented as this is how a dry cell can be represented. Now we shall see what are the reactions which occur in the dry cell. So we know at anode, zinc is oxidized to zinc 2 plus ions, losing 2 electrons. At cathode, 2 MnO2 in presence of ammonium ions and 2 electrons converts to Mn2O3 and ammonia and water are generated. So the net reaction can be shown as these 2 electrons on the product side and the reactant side cancel each other. It forms Mn2O3 plus 2NH3 plus H2O plus zinc 2 plus. It is in hereditary state and it is in the solid state. This ammonia gas, which is liberated, may disrupt the current flow, but it is prevented by its reaction with the ZnCl2 zinc chloride available in the electrolyte. So it forms the complex with zinc chloride and it can be shown by this reaction. Zinc chloride reacts with the ammonia gas to form so these are the reactions associated with the working of dry cell. It has advantage that it is very cheap and easy to use, but it has some disadvantages also. The first disadvantage is that this dye cell builds up product on the electrode if we take the current very rapidly. If current is rapidly withdrawn from it, then it builds up the product on the electrode, which causes drop in the voltage. And second major disadvantage associated with the dry cell is that this cell becomes dead after a long time, even if it is not used. So these are the two major disadvantages associated with the dry cell. However, it is frequently used in various applications like calculators, transistor radios, flashlights, wall clocks. So these are the places where dry cell is used. Now we shall discuss about the construction and working of lead acid storage battery. This diagram shows the construction of lead acid storage battery. We can see here are two sets of plates. This set of plate is made up of lead, and this is showing the anode. This set of plates shows cathode, and this set of plates is made up of lead oxide. Both sets of plates are immersed in the H2SO4 solution, which is kept in a container. So this is the basic construction of the lead acid storage battery. The lead acid storage battery has a unique feature that it can work both as the voltaic cell and the electrolytic cell. When it is working as voltaic cell, it converts the chemical energy into the electrical energy. And conversion of chemical energy to electrical energy is called discharging. On the other hand, when it works as electrolytic cell, it converts electrical energy into chemical energy. And the process of conversion of electrical energy into chemical energy is called charging. So when it works as electrolytic cell, it converts electrical energy into chemical energy, and this is called charging. During discharging process, it works as electrochemical cell and converts chemical energy into electrical energy. Here in the cell, in this battery, we have anode, which is made up of lead. So we have a lead grid filled with the spongy lead grid filled with spongy lead. At cathode, we have lead grid, which is packed with lead oxide. The H2SO4, which is filled here, works as electrolyte. So electrolyte here is H2SO4 solution, which is 38% by mass. The voltage of this battery is 12 volt because it is made up of 6 individual cells having 2 volt EMF of each cell. So each cell is having EMF of 2 volt and 6 cells are there. So total EMF is equal to 6 multiplied by 2 equal to 12 volt. Now we shall see the reactions which occur in the lead acid storage battery. During charging, when it supplies the current, the reactions cut. Now we shall see the lead acid storage battery reactions. We Now we shall see the reactions which occur in the lead acid storage battery. Cut. Now we shall discuss the reactions which occur in the lead acid storage battery. When lead acid storage battery supplies the current, it undergoes discharging. During discharging, the reaction happen as follows. At anode, lead is oxidized and combines with the sulfate ions available to form lead sulfate, and 2 electrons are released. At cathode, which is having lead oxide, it converts to lead sulfate. So the net reaction can be shown as These are the two electrons on the reactant side. These are on the product side. They cancel each other. So it forms Pb the 2 moles of lead sulfate have produced 1 mole and 1 mole. It is precipitated. Because these reactions are spontaneous, lead acid storage battery is undergoing discharging, so it releases some amount of energy. And because chemical energy is converted to the electrical energy, here it works as electrochemical cell. We can observe that as the battery provides energy, it is getting discharged. And this leads to the gradual formation of lead sulfate, which forms an insoluble layer at the electrode. It also leads to uh, a steady decrease in the concentration of H plus ions. So concentration of sulfuric acid is decreased. Now, when the battery is being charged, means when we are talking about the charging, when battery is being charged, at that time the reactions will be reversed. It means it will begin to behave like electrolytic cell, and because now it is behaving as electrolytic cell, the anode will work as cathode and cathode will work as anode, and the reactions will be reversed, means the products are converting back to the reactants. So reactions are shown as, now this becomes as cathode and the reaction gets reversed. So it is PbSO4 converts back to Pb, and SO4 2 minus ions, sulfate ions, are regenerated at anode. This reaction, which was occurring at cathode, it gets reversed. So it becomes PbSO4 it converts to PbO2 solid and SO4 2 negative. The sulfate ions are regenerated and 2 electron. So the net reaction can be shown as 2 PbSO4 plus 2H2O and plus some amount of energy, because this time we are providing the electric current. To get that energy stored in the chemical form, it converts to Pb solid plus Pb O2 solid. So these are the net reactions for, this is the net reaction for charging cycle. We can see that concentration of H2SO4 decreases during discharging, H plus is being consumed, whereas it increases during the charging cycle. So during charging reactions, H plus are regenerated. Thus, the extent to which the battery is discharged can be checked by measuring the density of H2SO4 by hydrometer. We can use this lead acid storage battery in the electrical vehicles, in laboratories, in hospitals, in the railways, in telephone exchange also. So these were the reactions of lead acid storage battery. Now we can see some questions which appeared in the previous year's exams. Define the term batteries. Explain the construction of lead acid battery. Write all chemical reactions taking place during charging and discharging of lead acid battery. So define the term batteries. We have already discussed it here. The combination of two or more galvanic cells electrically connected to work together and produce electrical energy is called as battery. And the reactions associated with the lead acid storage batteries have already been discussed here. This question appeared as differentiate between primary and secondary batteries. We have to highlight the differences between primary and secondary battery. Discuss the various reactions involved during the charging and discharging of lead acid storage battery. We have discussed primary and secondary batteries, their differences. Here we have discussed them. And the charging and discharging reactions of lead acid storage batteries have already been discussed in the first question. So this was about the batteries today. These are some of the suggested references. Thank you for attending this session.